Hello everyone. In this video I am going to walk through about the PPT video conferencing, and the project title happens to be implementation of one view multi-party video conferencing. So the justification of the title goes like this. So the video conferencing can be initiated with any multiple parties here, like whoever the parties have joined the video server, everyone will be listed out. So you people can choose anyone to have a video chat with. So but at any point of time you can have only one party at a time. So I mean only one view of the video at a time, either of the any one of the client. So we call it as one view multi-party video conferencing. So what are we going to see in this video is as follows. First let us solve the problem clearly, state the problem clearly, followed by let me tell you the existing solutions for solving that problem and their drawbacks, and proposed system and their advantages, followed by use case diagram and architecture diagram, and let us divide our entire project into smaller modules. Okay, so let's get started now. The problem statement here is everything what we have online video, it requires lot of bandwidth and resources. Okay, so if you can clearly see here, the problem statement says we need lot of bandwidth and resources for providing high quality of service. Okay, but this is not really suitable in case of real-time streaming. Okay, so because real-time streaming indicates an example for real-time streaming is the cricket match live coverage, or it could be an online training, or it could be an online meeting in the company, anything like that. Okay, so it's a live coverage. So in these areas and all, if we have if we want to reserve a lot of bandwidth and resources for achieving high quality of service, it will be delaying the buffering of video a lot. Okay, the lot of delay will be experienced. Okay, so this happens to be the problem statement. So for implementing this real-time streaming, the live coverage, the existing solutions we have is couple of protocols. One is the TCP protocol and another one will be the UDP protocol. Okay, so the how actually the TCP protocol will be working. TCP protocol will be working based on frame resending. Like if one source is sending the video frame to a destination, if the destination did not receive the frame in the order, it is going to ask to resend that frame. Okay, because if the frame have not been resent, then the quality of the video will come down. So the destination will be asking the source to resend the frame. Okay, so because of this frame resending and all, we will be requiring lot of buffer. Okay, and also we will be requiring lot of bandwidth in case of TCP and IP. And also if the frame has not been arrived at, it will keep on asking for resending. Say for example, within a second, 1 second video, there will be 24 frames that will be exchanged from source to destination. Even if any one of the frame gone missed, it will ask the entire 1 second video to resend it. So ideally a delay experienced in TCP and IP implementations is more. Okay, so whereas in case of UDP, right, UDP works in the fashion like send and pray. The meaning of send and pray is it will simply transmit the frames, but it don't know whether it is being received by the client or not. Okay, so whenever we have broadcast video implementations, we use this UDP protocol. Like whenever someone is announcing something in a mic, you don't bother if everybody is listening. Like the people at the end may not be listening to his announcement, but still he doesn't bother, he keeps on continuing. So that's how the UDP implementation will be working. Okay, so the disadvantages of these couple of protocols will be like this. So in TCP IP, as I told you, it will wait for acknowledgement. Okay, it will wait till the receiver sends an acknowledgement saying that I received the frame. If it doesn't receive the acknowledgement, it will resend the frame. So it requires a lot of buffer and also the bandwidth. So it will be used in loading the web pages and sending out an email, etc. Okay, like no matter how slow the internet is. If the internet speed is high, the web page will be loading very soon. If the speed of internet is low, the web page will be loading very slow. But at any point of time, the web page will load. Either fast or slow, the web page will load. So because we are using TCP, because it guarantees the delivery. It will wait for acknowledgement. If it not receives, it will resend the frame like that. And in case of UDP, it will work in the fashion of send and pray. Okay, it will be used for broadcast messages. So for that purpose, so what actually we are proposing is we are implementing an end-to-end practical demonstration of RTP, RTSP and RTCP protocol. Okay, so RTP stands for real-time transport protocol, RTSP stands for real-time session protocol, and RTCP stands for real-time control protocol. Okay, so using these three protocols, we are going to build an end-to-end implementation of video conferencing system, where the user can initialize the video conference with any of the other party who is online. Okay, and there will be multiple parties who can be online at the same time, but only one view of the video can be achieved at any point of time. That is the meaning of multi-party video conferencing system. Okay, so the advantages of our project will be we are going to achieve some something called live streaming of data. Okay, so live coverage we are going to achieve. So delay experienced will be very less. Okay, because RTP and RTSP works in a fashion like, okay, it will not bother about resending the frames. So even if within a 1 second video, if any frames in between gone lost, it doesn't ask for resending it. Okay, so what are we achieving is we are achieving lesser delay, but what are we losing is we are losing the quality of service. Okay, so in the proposed system, the quality of service will be down, but the delay achieved will be very less. Okay, so that is what, but that is what required in case of live streaming video conferencing, right? So no matter whether it is very high quality video or not, we need an on time video. So that is the whole agenda here, and of course we are not using any buffers, so no storage will be required. So, and most importantly, using RTP and RTSP protocol, the clients cannot save the video on their machines, like they will not be able to download the video. So it will also be a kind of secured in this way. Okay, like because we are not sending the entire video once, we are sending the video on time to time basis. Okay, so he cannot download the entire video in one shot, and it will be supporting multicast as well, meaning one video can be viewed by multiple parties at the same time using RTSP protocol. Okay, so these are the advantages of our proposed system. So now let us get into the use case diagram, the project architecture diagram. So if you can clearly see the use case diagram, so there are two users in our project. Okay, an user and a server. Okay, so two types of users will be there. So we call this guy as a client and we call this guy as an admin, a server. Okay, so first of all, the server should be coming into picture. So server should be first starting the video conferencing service, so using this component, and also if you don't want, you can stop the video conferencing system. Okay, and so from the user end, user can register to our project saying that I need to participate in video conferencing. You can log in and log out. Access control is log in and log out to the portal, and after he logged in, he can log into the video conferencing tool only if the server has started the service, or else he cannot log in there. Okay, and you can also see the buddy list, like which are all the friends currently online. You can view using this component, and you can initialize a text-based communication chat with any of the buddies that are online at any point of time. And of course, you can also initiate the video-based conference with the online buddies. Okay, so this buddy list, text chat and video conferencing, if you can see, all of them will be using this implementation, RTP, RTSP and RTCP implementations. So that's about the use case diagram. So coming to the project architecture diagram, as I told you, we will be having a video conferencing server on the one end and video conferencing client on the other end. Okay, so video conferencing server will be used to implement the start and stop operation, and client will be used to implement the login, logout, text-based chat and video-based chat with respect to all the buddies online. Okay, but for integrating both of them, we do provide something called user interface. Through this user interface, the admin can access this start and stop, whereas the client can access this login, logout, text-based chat and video-based chat. Okay, so this user account services are for registering a new account within our system. So users will first come and register their account with our system. So only after registering they can log into the video conferencing, right? So that's about the data flow diagram, the project architecture diagram. So now if you come across the modules breakdown, so our entire project will be just a minute. So if you want to divide our entire project into smaller module, the very first module will be the DAO layer. So hope in the basic training you people were being introduced to the concept of DAO and all. So any database we are going to create, like for storing the username and password information and all, so that database cannot be accessed directly. So instead the database will be accessed through the DAO layer. Okay, so this is one of the coding standard we learned in the basic training. And in module 2 we provide user account services, like registering a new account, logging into our project and log out from our project. All those things you can do using this module. And in module 3 we are going to practice some examples on RTP and RTSP protocol, because these two protocols were not the part of our syllabus academics. So we need to first practice some hello world examples. So probably you remember that we had done some sample examples on how to connect two different machines over the internet, how to ping one machine to another machine, and how to exchange the text-based communication from one machine to another machine. The command line chat and all you people have done. So that is what we call module number 3. And in module number 4 we are going to implement the client side of video conferencing. So this is the major part. And in module number 5 we are going to implement the server side of the video conferencing, like how the server will be receiving the client request, how the server will be maintaining the buddy list, okay, and how one client can initiate a chat with another client. All those things and all we are going to do here. And in module 6 we are going to implement the admin services, like starting the server and stopping the server. In module 7 we are going to implement the client services, like viewing the buddy list and starting the text based chat and starting the video based chat, all those things. Okay, so that's how our entire project will be divided into 7 modules. Okay, so hope this PPT was clear. Thank you so much.